Hello, this is our video for the second lesson in Algebra 1, which normally I would have made during class, but I was still figuring out my software, so I didn't, and now I'm making it. If you need it to pause the video at any point to try something out that I'm asking you to do, then do that and hit play when you're done. So today we're learning, actually I understand now that it's more of a review, order of operations. And order of operations is necessary because when an algebraic expression has more than one operation involved, then you need to know how to do it. Everything we did in the last lesson, there was only one operation. Or in the case of a power, it was, first you had to turn it into a multiplication, but in the end it was just a multiplication. So here's examples of the kind, these are coming from the homework section at the end of this lesson, but as you can see, in all of these arithmetic expressions, because there's no variable, there are more than one operations involved. And most of these, I think when you look at them as numbers, that you're likely to have more success with them than you will when we start doing them with algebra. But I can tell you that something like, let's say, 2 plus 3 times x plus 4 is commonly not dealt with correctly in algebra. That students want to add these so that it's 5 times x plus 4. And order of operations would tell us, no, you don't do that. You would do this multiplication first, which means you would do distributive property. And then possibly you'd have something to add. But, unless you've got a really strong understanding of the order of operations when we do it with numbers like we're doing it today, you'll have problems later on when we do it with algebraic expressions. In this textbook, which is the first textbook that I've seen do this, they give you all the order of operations there and they do it correctly, no issues with that at all. But they don't use the one thing that you probably are already familiar with when it comes to order of operations, and that is PEMDAS. Right? P-E-M-D-A-S.
Teachers, at this time, please release all sophomores to the auditorium. Students, leave your belongings in class. You will report back to 2AB. Thank you.
So in PEMDAS, the P stands for parentheses, and they have grouping symbols in their first step. The E stands for exponents, and they say powers. And the M and the D stand for multiplication and division. There you go. And the A and the S, addition and subtraction. There you go. Keep in mind that when you get to these two steps, that what it's telling you to do is consider multiplications and divisions together as you go from left to right. If the first thing you encounter is a division, then do the division. If the first thing you encounter is a multiplication, do the multiplication. I had a student tell me a couple of years ago that PEMDAS was wrong and that there was a YouTube video to that effect. You can check it out and see whether it's still there, but it was there. I went home and looked at it. And what the video said was that sometimes this part of it, considering multiplication and division together, addition and subtraction together, is not taught correctly. But PEMDAS, properly taught, is still correct. Don't doubt that. So let's use PEMDAS to evaluate this expression. First, there are no parentheses, so we don't need to do anything there. Second, there is an exponent here, so we should do that step first. 27 divided by 9 times 2 minus 3. Okay, then multiplication and division considered together from left to right, the first thing we come across is this division. So we need to do that. 27 divided by 9 is 3. And now we can do the multiplication, which is 3. Okay. This is the first of our U-tries that we do in class. I'm going to go ahead and do them. If you want to pause the video and then try them yourself and come back, hit play, and see how you did. Okay, on number 1, there's only 2 things going on. There's a power and there's a subtraction. And we would do by PEMDAS, we would do the exponent before we would do the subtraction. So we'll go 20 minus 16, and then 20 minus 16 is 4. And the next one, again, we have an exponent. We have 3 operations. We've got an exponent, we have a multiply, and we've got an add. First comes exponent. 2 times 9 plus 4. Then multiplication comes before addition, so we multiply. And then we finally add to get 22. Now understand that the P in PEMDAS stands for parentheses, but could be any grouping symbol. And usually if there's more than one kind of grouping symbol, it's because one of them is inside the other. I mean, almost always what you'll see is like parentheses and then maybe square brackets on the outside. Okay, you would always do the inner first, right? Go to inner. Grouping symbols. First. And I don't think we get to any other grouping symbols in this class, but I can tell you that in my math career, I can remember having more than just 2. So you can have many different layers that you've got to, get to the inside of. So evaluate this expression. So they said the thing they do about grouping symbols, so that now they're going to give us a couple expressions that involve grouping symbols. So there are 2 things going on in this problem. There's parentheses, which enclose an operation, so we're going to have to do that. And then we're going to have to multiply 7 times. So this here will go 7 times 13 minus 8 is 35. Next. Go ahead and try these. Pause the video if you need to, and when you're ready, hit play. Let's see, the first 2, there's only one set of grouping symbols, so that should be pretty straightforward. I mean, this one here has got the grouping symbols, and it's got to multiply just like the last one. 4 times 12, which is 48. Right, this one's got 3 things going on. Right? It has the grouping symbols, it has an exponent and subtraction inside, and it actually has a multiply. So you could think of that as 3 or 4 different things going on. So first we need to attack what's inside the parentheses. Okay, and considering 8 minus 2 squared, we do the 2 squared first. 3 times 8 minus 4. Now we go still inside the parentheses. 3 times 4 equals 12. And now finally in the third one, we actually do have nested grouping symbols, parentheses inside of square brackets. So we should go to the inner grouping symbols first. So this will be 2 times square bracket 12 divided by 4. Right, now inside the square brackets, 12 divided by 4 is 3. And then 2 times 3 is 6. Honestly, now that I'm thinking about it, I can tell you that most of the time that I see nested grouping symbols, we just use parentheses. I mean, you can see like parentheses, inside of parentheses, inside of parentheses. As long as you've got the same number of left parentheses and right parentheses, it should be clear. Okay, now we've got a fraction. And fractions have an implied grouping symbol around the numerator and the denominator. You don't see it there, but you need to make sure that you've simplified the numerator all the way and simplify the denominator all the way, and then you'll deal with that fraction bar as a divide. So we're going to consider it like this. This is going to be 9x and square brackets 3 times x plus 2. And now this is actually an evaluate an expression given the value of the variable, so we're going to have to do this in steps. Right? First, we're going to plug in the place of x. We're going to put a 4. Right? Now I'm going to keep the parentheses there, but you don't have to. But you got to remember not to do any kind of simplifying between numerator and denominator until you've completely simplified both. Right? So let's say parentheses 9 times 4. And then we've got square bracket 3 times 4 plus 2. Okay, and let's see how we want to do this. I'm not going to simplify the numerator yet. I'm just going to write it like this. Is that right? Looks right. Okay, so now in the numerator, I'm going to simplify this by going 9 times 4 is 36. Denominator is 3 times 6, which is 18, which makes this whole thing 2. Now, if you didn't consider, like I said, that the grouping symbols around the numerator and denominator, you might look at that like it's like this, right? 9 times 4 divided by 3 times 6. And that would not be correct. Right? If you just did the multiplication division from left to right, you would do 9 times 4, then you would divide by 3, and then you would multiply times 6. You would not have ended up having the effect of having a 6 in the denominator. It would be like the 6 was in the numerator. So you definitely don't want to do this. That's not what that means. Okay, last of our U-tries for today. Today was a short lesson because virtually the whole class had an assembly. So that's why this was short. So go ahead and evaluate these 3 expressions when y equals 8. Now I'm going to go ahead and do them. 8 squared minus 3 is 64 minus 3 is 61. 12 minus 8 minus 1. Okay, there's more than one thing going on. We should do the addition and subtractions from left to right. So first we do the 12 minus 8 is 4. And then we do 4 minus 1 is 3. And finally, again, now here's our fraction. Here's where we've got to consider as if there were grouping symbols around the entire numerator and the entire denominator. So this is 10. Excuse me for this. 10 times 8 plus 1 divided by 8 plus 1, which is 80 plus 1 over 8 plus 1, which is 81 over 9. Now I divide 9. Okay, I didn't even call this a U-try in class. I just said, hey, let's try this problem. I would guess that if you get a problem about evaluating algebraic expressions on the SOL, that it's going to look something like this. And what I really want to emphasize for a young class in Algebra 1 is to not avoid the word problems, especially when you see a word problem at the end of a homework section. you're pretty sure the word problem is about exactly what you've been doing up to that point in the homework assignment. And if you look hard enough, what you're going to see is there's a bunch of words, there's the algebraic expression, and there are values for the variables so that you can evaluate the algebraic expression. And that's it. I mean, if you just don't just turn away from it and say, I don't do word problems. Look a little harder, try a little harder than that. As you go higher in your math career, you definitely are going to have to be doing word problems. And I would hope that we all aspire to keep all of our options open when it comes to career choices and things like that. And you don't get there if you're avoiding the word problems that are supposed to be putting together, the real process kind of things that we've been doing into a problem-solving kind of a event, let's say. So we can see in all the words here, and you can read those words, it's coming down to the fact that there is an algebraic expression, and there are values for the two variables, right? There's a J for juice, is $1.25. There's an S for sandwich, which is $2. So plug it in, simplify. 12 times 3 times 1.25 plus 2 times 2. And notice I just used parentheses inside of parentheses. I didn't even use the square brackets. 12 times, and I know we get challenged with our arithmetic here. Most of you, if I said, what's 3 times $1.25, you'd say $3.75. But if I said 3 times 1.25, you'd say, I don't know. But it's actually 3.75. $12 times 7.75. Now, if you're not dealing with a calculator, and we're not, I can tell you the way that I looked at this problem. I mean, I didn't have a calculator, and I'm not doing 12 times 7.75 in a long multiplication problem in my head. What I did is I looked at it like this. This is 12 times 7 plus 0.75 plus 30. And that, if you think 0.75, that's 3/4. So now we're doing distributive property. 12 times 7 is 84. And 12 times 3/4. What's 3/4 of 12? And that is 9. Plus 30. So this is 93 plus 30, which is 123. Okay, find the errors in these two problems. Again, if you want to pause, you can pause, but I'm going to go ahead and talk about it now. Let's see, they went they went to the parentheses first, did 1 plus 13. That's correct. What should they do next? Let's see, there's a division and there's an addition. What do we do next? Should be the division. The next thing we should be seeing here is a 2. 14 divided by 7 is 2. Instead, we see that they did the addition first, which means they didn't use the order of operations correctly. So that is the problem there, right? Should have been, from there, it should have been 2 plus 7, which is 9. Let's see this one. First thing they should have done is 6 squared because of the exponent. But it looks like they went from this line to this line by doing 1/2 of 6. So they multiplied before the exponent, and according to PEMDAS, we should have done the exponent before the multiplication. So this should have looked like 20 minus 1/2 times 36, which is 20 minus 18, which is 2. So that is the lesson. I'm just repeating the essential learnings that come from the SOLs, but essentially we're evaluating expressions and using order of operations. The homework, page 10, 3 through 17, 23 through 27. Somehow when I brought this up in class, that didn't work, but it works now. Remember that when it says odds, with an S on the end, that means these are odd and these are odd. There was a little confusion about that, but not much. Okay, so enjoy.